हेलो गाइस, वेलकम बैक आफ्टर क्विक ब्रेक। आज हम सॉल्व करने वाले हैं एक और प्रॉब्लम। हम आज सॉल्व करेंगे कोडशेफ के ऊपर। एज यू कैन सी ऑन माय स्क्रीन, दिस इज़ वर्जन कंट्रोल सिस्टम एंड इट हैज़ अ स्लाइटली हायर डिफ़िकल्टी रेटिंग। सो पहले हमने जो सॉल्व की थी प्रॉब्लम वो 1100 थी. Now we have like just jumped on to a 1200 difficulty rating problem, but it is also a basic implementation sort of a problem. So यहाँ पर भी we are not thinking about very deep in terms of algorithms, but we will see like how we can improve, right? तो let's start. Okay. तो सबसे पहले अपन अपनी प्रॉब्लम पढ़ते हैं कि प्रॉब्लम क्या है. Okay. So a version control system is a repository of files, often the files for source code of computer programs with monitored access. Every change made to the source is tracked along with who made the change, why they made it, and reference to the problem fixed or enhancement introduced by the change. So basically a version control system, more likely like GitHub, GitLab, right, if you have heard of. So these are like version control system. That's what he is talking about. Okay. So version control systems are essential for any form of distributed collaborative development, whether it is the history of a wiki page or large software development project. The ability to track each change as it was made and to reverse changes when necessary can make all the differences between a well managed and controlled process and an uncontrolled first come first serve system. So basically you have all those git commit, git revert, git push, right, all those commands to basically go up and down in the history to check. So basically this is just he is just explaining like what a version control system is, right? It can also serve as a mechanism for due diligence for software projects. In this problem we will consider a simplified model of a development project. Let's suppose that there are n source files in the projects. Okay, so basically he has given the first input parameter n, which is the number of source file in the project. Okay, all the source files are distinct and numbered from 1 to n. Okay, that is very simple. A VCS that is used for maintaining the project contains two sequences of source file. The first sequence contains the source files that are ignored by the VCS. Okay, so a VCS, the system, he is talking about a system. So basically the system contains two sequences and the first sequence contains the source files that are ignored by the VCS. So if a source file is not in the first sequence, then it's considered to be unignored. Okay, and the second sequence contains the source files that are tracked by the VCS. If the source file is not in the second sequence, it's considered to be untracked. So a source file can either be or not be in any of those two sequences. So it can either be in ignored, it can either be in tracked, or it can either be in both, or it can be in neither of them, right? So that all possibilities are there, all four possibilities are there. Your task is to calculate two values: the number of source files of the project that are both tracked and ignored. That means that both are that basically जो फाइल है वो हमारी दोनों सीक्वेंसेस के अंदर है. फर्स्ट दैट वी नीड टू कैलकुलेट, एंड सेकेंड नंबर इज बेसिकली द नंबर ऑफ सोर्स फाइल्स ऑफ द प्रोजेक्ट दैट आर बोथ अनट्रैक्ड एंड अनइग्नोर्ड. बेसिकली विच मीन्स दैट वो फाइल दोनों में ही नहीं है, राइट? बोथ ऑफ द सीक्वेंस इट डज नॉट एग्जिस्ट. ओके, so the first line of input contains an integer t denoting the number of test cases. So from the last problem, as we are actually working on it, you are getting the things right. So basically in a single sort of a run, it will give you t test cases, right? So that's mostly going to be the case, that you are going to get t test cases, and for each test case you have to output something, and the idea is that this t is also very important, right? So the first line of the test case description contains three integers n, m and k. What are these? Denoting the number of source file of the project. So n is the number of source files, m is the number of ignored source file, and the and k is the number of the tracked source files. That is fine. And the second line contains m distinct integers denoting the sequence a of ignored source files, and the sequence is strictly increasing. So यहाँ पर भी हमारे को एक increasing sequence दिया हुआ है, sorted sequence दिया हुआ है, which is fine as in our last problem. And the third line k contains distinct integer denoting the sequence b of tracked source files, and the sequence is strictly increasing. So that is also strictly increasing, means that basically that since, and this has to be the case because the number of files which are there, they are all distinct and numbered from 1 to n. So basically your sequence, if it is sorted, then it is going to be strictly increasing, right? Because no two files can have the same number. For each test case, output a single line containing two integers, the number of source files that are both tracked and ignored, and the number of source files that are both untracked and ignored. In simplistic word, basically he has given us two sequences, and we want to find out the number of files. We want to find out those numbers which exist in both of the sequence, and we also want to find out the numbers which does not exist in either of the sequence. Okay, so let's start. So we will first start a very brute force kind of an approach, because this is a very basic problem. So let's start with it. We'll first take integer t. Let's take our integer t, and then we will have a while loop. Okay. Then he is saying that he will give us n, m and k. So basically we will have to take three integers, n, m and k. So we will have n, m and k. Okay, and then the numbers of the files are from 1 to n, that we know, and then basically the sequences have m and k. So so first sequence will be of size m, right? So basically we need to have a loop. Okay, now we will again have a vector as in our first problem. तो सबसे पहले अपन वेक्टर इंक्लूड कर लेते हैं. Include is wrong. Yeah. Okay, now basically what we will have here is the first files are ignored, so basically ignored files. Okay, and then there is tracked files, right? So basically we will take tracked files. Okay, now we will have ignored files dot pushback the file number, right? So basically we will take the file, and we will have dot pushback. And then there is tracked files, right? So basically we are taking the input for the file numbers and inserting it in ignored and tracked. This is good. Okay, so now we have taken all the inputs of the files which are basically being tracked and which are basically being ignored. Now what we need to do is we need to find out the numbers from 1 to n which are in tracked and ignored, and which are in neither of them, right? So basically what we will do is we will start with our file number from 1 to n, since our file goes from 1 to n, right? So these are our files, and we want to find out if this particular file is basically in both, or it is basically in neither of them. So basically we will go bool tracked and bool ignored. This is a very basic implementation, a very naive implementation for it. So let's just do it. Int I is equals to 0. We are just going to check whether the approach actually works or not, right? Now basically we will go in our ignored files, and we will check if the file is basically being ignored or not. So ignored we will first have if it is, so we will first assume that the file is neither being tracked and not being ignored. Otherwise what we will do is basically we will check ignored, or basically if a file is in there. So basically we will have ignored files of I if it matches I. If it matches our file number, that means that our file is in here. And similarly we can have a check here that if the file is not already ignored, then only basically continue the loop. Otherwise if it is being ignored, if you have already found one match, then basically there is no need to go further, right? That's one of the optimization that we did in the last problem, so we are going to take from that. Similarly, we are going to code for tracked. Yes, so now we have ignored and tracked. There is a spelling problem, so let's fix it. Yeah, now if the file is tracked and ignored, then we want to count something, and if the file is not tracked and then not ignored, then basically we want to count something, right? And we want to have two numbers, so we will take two numbers, tracked ignored, untracked unignored. Okay, and we will have them initialized with 0, and let's count them up. Okay, and now we will just output our values. So basically we will have tracked ignored space handle, and this will actually print the output for us, right? So let's run it. So our output is coming out to be wrong. It has to be 1 1 and 0 2. So let's check where we have done the mistake. Okay, so the problem is in our loop, where we are actually having the first loop with m and the second loop is with n. So this loop has to go till k, and that's why the output is wrong. So let's run it again. Yes, now the output is correct. Let's submit it. And it's showing the correct answer. But is this code optimal? That's come the question. So basically वापस से वही क्वेश्चन आता है कि क्या ये कोड ऑप्टिमल है या नहीं है. तो why not those guys who really want to prepare, here is a chance to pause your video. आप वीडियो को पॉज करो, थोड़ी देर के लिए सोचो कि इस कोड में अपन क्या इम्प्रूव कर सकते हैं, क्या टाइम कॉम्प्लेक्सिटी आ रही है, क्या स्पेस कॉम्प्लेक्सिटी आ रही है, किस तरीके से इसको और बेटर किया जा सकता है, कहाँ कहाँ इम्प्रूवमेंट के स्कोप्स हैं, ठीक है. और फिर अपन और उनके क्या क्या रीजंस हैं कि लाइक वाई दिस कोड इज़ नॉट ऑप्टिमल, ठीक है, और कैसे हम इसको बेटर बना सकते हैं, वो चीज़ हमें सोचनी होगी, तभी हमें बेसिकली कुछ फ़ायदा होगा, राइट. एंड फॉर दोज वो रियली वांट टू एंजॉय द शो, हियर इट इज़. ओके, सो for those who think that this can be improved and who have thought around कि okay these two for loops can still work like our last problem, कि हम इसको binary search के अंदर वापस से convert कर सकते हैं. Yes, you are correct, because right now this is almost around n square in terms of the time complexity, क्योंकि अगर आप m और k देखोगे तो m और k की जो m and k are order of n, right. So basically this overall loop is big of n square, so this can be improved. And what we can do is like we can just have like something like this, कि if this file exists in the ignored file list, or sorry, this exists in the tracked file list, right. So tracked files dot begin, tracked files dot end, and then basically the file number that we are trying to find out. And similarly, if this file exists in the ignored files dot list, right. correct, then this solution would work. Yes, so let's run it. This is a very simple optimization like our last problem कि हम इसको binary search पे लेके जाते हैं. Okay, so it couldn't find binary search. Why? Because as usual we forgot to include algorithm. So let's include algorithm here. Let's run it again. Yes, and now I'll submit it. Okay, we have our correct answer here because we have solved this problem. But again the question comes is this solution still optimal, right? So if you look at it, it is not, and here it is why. Okay, so the idea is that the right now we are having two vectors. Okay, and for each file we want to know whether the file is either in both of the list or neither, or it does not exist in any of the list, right? So that's what we want to track, and for that what we need to do is like we can keep this information tracking per file instead of storing the file numbers. So right now if you look at these vectors, okay, these vectors are basically storing the file numbers, okay, for each individual property that those file has. Like basically if the file is being ignored, then this file will be present in the ignored file list, okay, and if the file is being tracked, it will present in the tracked file list, okay. But if we just, for the sake of this problem, if we just assume that these are the only two lists, okay, that we need to keep track of, okay, तो उस केस में basically we can store these properties in some more integral way, right? Basically we just want either they are in both of them or not. So what we will do is we will have a files vector instead of this ignored files and tracked files, and basically whenever, and we will initialize this file vector with 0 for each and every file. So I will go from 0 to n, okay, and I will do files dot pushback 0. So initially what I am doing is basically I am saying that the files are not in any one of these vectors, not in the ignored files list or not in the tracked file list, and then we have the loop, okay, the m loop and the k loop, which actually takes the input of what are the files which are in the ignored file list. So what we are going to do is, instead of pushing this into a vector, what we can check is if the files array for this particular file has that whatever the value it is there, I will just increase it by 1. So that means that basically once I see that the file is in the ignored list, I will add 1 to it, and similarly if it is in the tracked file, I will add 1 to it. So yep, and now our question becomes very simple, that this files array now contains some numbers 0, 1, 2. 0 means basically the file is not present in any of these lists, either in ignored or in tracked. If it is having 2, it means that it is present in both the list, in ignored and in tracked, okay. And if it is having 1, then basically it means that it is present in one of the list but not in both, right? So we just want to really count the zeros and 2, right? So for that what we can do is we can have our n loop, okay, and we can get rid of this. Yep. And now what we want to do is we want to just figure out the count of the files which are tracked ignored. So basically if it is being tracked and ignored, then this value will be 2. So this value will be tracked and ignored, and if the files of file is 0, that means that basically the well, that basically neither it is tracked or nor it is ignored. So we will increase the count there. And now let's run this particular code. We have the same output, but what are the benefit of this code? So we have reduced the time complexity way further. So first we had an big of n square approach. There we optimized it to binary search, but then we thought, like, why not just have some integer frequency like 2 or 0 or 1 to actually keep track of in how many number of lists this file is present, right? And for that we just kept a single big of n vector. So we increased on our space a little bit because m and k are also in big of n, so if you look at it, but we just did that, and then we basically started running the loops from I is equals to 0 to m, and then basically k. We just take those inputs, and whatever the file number is there, basically we increase the frequency accordingly. And in the last we just checked for key whether the files are having the frequency 2 or whether the files are having the frequency 0. If they are having the frequency 2, that means that basically they are being tracked and ignored, otherwise they are basically being untracked and unignored. So if you look at it, all the loops are single loops, there are no nested loops, there are no binary search, and basically the time complexity is big of n. So we have reduced it further, and now let's look at it. Yes, so now this is 4 1 and 1 1, right, and which is fine. Now we can submit it. So what's the big idea? Why did we go into a step further and improve it a little bit more, right? So the idea is that कि right now I'm practicing, right now you are practicing with me. तो जब भी हम प्रैक्टिस कर रहे हैं तो हमें बेसिकली प्रैक्टिस करते वक्त हमें उसको डेडिकेशन से करना होगा कि लाइक कोड एक बार अगर सबमिट होने के बाद ऑनलाइन जज ने एक्सेप्ट कर लिया, इट डज नॉट मीन दैट इट इज़ द बेस्ट कोड, राइट? It just means that it actually satisfies the criteria of the problem. So as I mentioned earlier, if you look at the test cases and the values of the m, k and n, these are very small, right? So if you look at n, the size of n is 100. So 100 into 100 is 10 to the power 4 into 100 is 10 to the power 6. So basically that is like, yeah, that will get passed. But roughly when you actually multiply these numbers together, right, n square into t, that is coming out to be 10 to the power 6 right now, so that will pass. But for the bigger problems, higher difficulties, these numbers will go to 10 to the power 8, 10 to the power 9, and there you will see TLEs, time limit exceeded exceptions, right? And those are the things where you will need to think about it, right? So in time pressure, you might want to just solve it a little and basically give it a go, but when you are practicing, right, you do not have any time pressure. So basically think around the problem, think around what are the ways to solve it, think around what are the ways to improve it, right? And the more you think, the more habitual it will become, and it will strike you even little faster. So like right now when I look at this problem, I might see this as my first strike, okay, I can just do this, कि input लेते वक्त I can keep the frequency array and basically do this, right? Or I can keep a map and basically do this, and just big of n loop and basically I can do that. So that will strike you way forward if you keep on practicing a little bit more, right? But if you just leave the problem at its brute force level solution, then basically even in practice when you are going beyond 1200, 1300, 1400, let's say if you are going to solve 1900 problem, then basically the solution might not work, and you will have to think why, right? So there it will come the question कि कैसे करें इसको. तो उस टाइम पे बेसिकली हमारी ये जो प्रैक्टिस है इसके अंदर हम इसको और कितना इम्प्रूव कर सकते हैं वो हमें देखना पड़ेगा. उसके बाद भी बेसिकली अगर आपको लग रहा है कि आपका सॉल्यूशन अच्छा नहीं है, राइट, और आपको लग रहा है कि अभी भी इसमें कुछ और इम्प्रूवमेंट के चांसेस आपको ऐसा लग रहा है, हंच आ रहा है कि भाई आपको हंच आ रहा है कि बेसिकली मुझे इसको और इम्प्रूव कर लेना चाहिए था, तो आप क्या कर सकते हो, आप सॉल्यूशंस पे जा सकते हो. ओके, यहाँ पर सॉल्यूशंस अब इन्होंने हटा दिए हैं, बट यू कैन गो टू द सॉल्यूशंस ऑफ अदर पीपल, ठीक है. यू कैन लुक अराउंड देम, you can see their code ki like what they have done in practice, right, and you can match your code with them. So let's say if I look at this guy's solution, right, उससे भी आपको बहुत सारा आइडिया हो जाएगा, उससे भी आपको ये मालूम पड़ जाएगा कि हाउ वेल यू कैन एक्चुअली सॉल्व द कोड. सो ही हैज सॉल्व्ड अ लॉट ऑफ प्रॉब्लम्स, राइट? और so this is what the profile looks like for a person who actually is sort of starting and want to just code. So look at the practice problems that he has solved, right? And after that he has started going into the context. So that is what we want to do really. If you want to actually solve some problems, प्रैक्टिस में जाओ आप, ठीक है? आप उसको थोड़ा सा देखो कि हाँ भाई कहाँ तक कितना आप प्रैक्टिस कर सकते हो. 100-200 प्रॉब्लम्स, 300 प्रॉब्लम्स, 400 प्रॉब्लम्स, धीरे धीरे अपनी डिफ़िकल्टी रेटिंग वाली प्रॉब्लम्स को बढ़ाते चले जाओ. एंड स्लोली एंड स्टडीली यू विल इम्प्रूव. ओके, थैंक्स फॉर दिस. वी विल कम विथ more questions. This is not the end, okay? Not with just these two problems. So basically, as you are seeing, like we have started with 1100, now we are at 1200. Slowly and steadily, basically we will improve. We will also pick up sometimes a problem which is more interesting but has a slightly lower difficulty to basically grasp on the concept better. For example, right now with these two problems we have solved binary search, we have seen some sort of a mapping, like basically how to keep a frequency or a hash map kind of a thing, where you can use which you can use to actually improve on the time complexity of the problem. Slowly we will incorporate more ideas into our solutions or our solution box, and basically we will implement those to solve these interesting coding problems, and we will have our solutions accepted over CodeChef. So do subscribe, do watch regularly if you really want to improve. Thank you. Bye bye.